All right. Today, we're going to dive into a really fascinating virological puzzle, one that has special relevance for us here in the Netherlands. Hantavirus. You know, it's one of those pathogens that really challenges how we think about diagnosis and treatment, and it forces us to kind of step back and look at the fundamentals of viral disease.
And just a quick heads up before we get started, all the information we're covering was compiled using a deep dive into the current research. If you want to check out the original studies for yourself, a detailed list of all the sources is available in the Notebook LM document linked for you.
So let's just start with the central paradox, the thing that makes this virus so incredibly interesting. What if I told you a pathogen could cause severe, life-threatening shock and organ failure, all without directly destroying a single one of your cells? I mean, that sounds impossible, right? But that's not a hypothetical. That is exactly what hantavirus does.
Now let's bring this story right here to our local context. Here in the Netherlands, and really across most of Europe, when we say hantavirus, we're almost always talking about one specific type, Puumala virus. It is a classic zoonosis, meaning it jumps from animals to humans, and its natural home is in the common bank vole.
So when someone gets infected with Puumala virus, they develop a very specific clinical syndrome that we call Nephropathia Epidemica. Now, technically, it's a type of hemorrhagic fever with renal syndrome, or HFRS for short, but it's a much milder version. In the clinic, what we see is this classic triad of symptoms: fever, a sharp drop in platelets, and acute kidney injury.
And when we say mild, the numbers really back that up. The case fatality rate for Nephropathia Epidemica is less than 1%. So, for a Dutch clinician, the takeaway is that while it's definitely serious enough to land someone in the hospital, it is very rarely fatal. But, and this is a huge but, this low number is incredibly deceptive when we start to look at the global picture.
So let's zoom out now and look at the bigger picture. Because this one family of viruses, the hantaviruses, is responsible for two completely different diseases around the world. And understanding this global spectrum is absolutely key to getting why these viruses are so unique.
So the two major syndromes are, on the one hand, hemorrhagic fever with renal syndrome, HFRS, which is what we see with the Old World viruses in Europe and Asia. And on the other hand, you have Hantavirus Pulmonary Syndrome, HPS, which is caused by New World viruses found only in the Americas. It's wild. One virus family, but two totally different targets, either the kidneys or the lungs. And this table here just lays out the differences so clearly. For HFRS, the target is the kidney, the geography is Eurasia, and the culprits are those old world viruses like our Puumala and its cousin Hanta. For HPS, the target is the lungs, the geography is the Americas, and the bad actors are the new world viruses like Cynombre virus.
And this chart just says it all. Look at the Puumala virus, our local concern, with that fatality rate way down under 1%. Now compare that to another old world virus, Hanta, which can hit 15%. Then look over at the New World HPS viruses, like Cynombre, with a staggering case fatality rate that gets close to 50%. How is that possible? How can one family of viruses have such wildly different outcomes?
Well, the answer to that question lies in this pathogenic paradox. You see, the damage isn't actually coming from the virus itself. It's coming from our own body's over-the-top reaction to it. And that right there is the key to this entire puzzle.
This quote from the research is probably the most important clue we have. The virus infects the endothelial cells, the cells that line all our blood vessels, but it doesn't kill them. It doesn't lyse them. It's basically a stealth infection at the cellular level. So if the virus isn't blowing up the cells, what on earth is causing the catastrophic leakage from the blood vessels?
It's our own immune response. The virus is just quietly replicating inside these cells, and this triggers a massive, completely dysregulated immune attack, a classic cytokine storm. It's this intense inflammation that literally rips apart the junctions between the endothelial cells, causing this profound leakage from the capillaries. This one single event explains both diseases. Where that leakage happens determines everything. If it's in the kidneys, you get HFRS. If it's in the lungs, you get HPS.
Okay, so this totally unique way the virus causes disease has direct, and I mean direct, consequences for us in the lab. It basically dictates our entire diagnostic strategy. If the disease is the immune response, well then that's exactly what we need to be looking for.
So here is the crucial point for diagnostics. The window of opportunity to actually find the virus floating around in the blood is incredibly short. By the time a patient feels sick enough to go see a doctor with what they think is just a flu, the viremia is often already gone. Trying to find the virus at that point is like showing up to a crime scene hours after the culprit has already cleaned up and left.
And this leads to a really clear conclusion for any clinical microbiology lab. Our standard tools, the things we reach for first, are basically useless for routine hantavirus diagnosis. Viral culture is a no-go because the virus is non-cytopathic. It doesn't cause any visible damage to the cells in the dish. And PCR, our go-to molecular tool, is very likely to come back negative because of that super brief viremia.
So what's a microbiologist to do? We have to look for the evidence left behind. The footprints, which is the host's immune response. The gold standard for diagnosing hantavirus infection, hands down, is serology. The body launches this incredibly powerful and persistent IgM antibody response, and that is the signal we can reliably detect. For hantavirus, we don't diagnose the virus, we diagnose the reaction to the virus.
Now, as you can probably guess, this immune-driven disease also creates a massive treatment conundrum. I mean, if the damage is basically friendly fire from the patient's own immune system, how do you effectively treat the disease? Well, this dark answer is we don't really have a specific cure. The foundation of management is just meticulous, aggressive, supportive care, and that usually means a trip to the ICU. We're talking about incredibly careful fluid management, trying to keep organs perfused without making the capillary leak worse, supporting the kidneys and HFRS, sometimes with dialysis, and managing severe heart and lung failure in HPS.
But what about antivirals? There is one drug that's been seriously looked at, and that's the broad-spectrum antiviral ribavirin. But the evidence for using it is, to put it mildly, really conflicting, and it seems to be highly dependent on which hantavirus you're talking about.
So, one of the big trials showed that for severe HFRS caused by Hantavirus, giving ribavirin early on dramatically reduced mortality. Great news, right? But, and for us here, this is the critical part. A later trial found it just didn't work well enough against HFRS caused by Puumala virus, our local strain. And for HPS over in the Americas, trials have shown no clinical benefit at all. The data is pretty clear. What works for one hantavirus does not work for them all.
So if the disease is driven by the immune system and our specific treatments are lacking, it really leads us to one inescapable conclusion. The only truly effective strategy we have is prevention.
And prevention is all about breaking that chain of transmission from rodents to people. For the general public, this is pretty standard advice. Rodent-proof your home, and when cleaning up infested areas, use wet cleaning methods with disinfectants so you don't aerosolize the virus particles. And it's also really important to highlight the specific advice from the RIVM regarding high-risk households. So homes with young kids, pregnant women, or immunocompromised people, they should really be advised against keeping pet rodents.
And that really brings us to our final thought. Hantavirus forces us to confront this fundamental challenge in infectious disease. We live in this amazing age where we're developing these incredibly specific, targeted antiviral drugs. But how do we manage a pathogen where the real problem isn't the virus itself, but our own overwhelming response to it? The answer probably isn't going to be a new drug, but maybe better ways to gently control the immune system.
And that's our look at hantavirus. We really hope this deep dive into its unique pathogenesis and clinical challenges was useful for you. For more expert explainers on key topics in microbiology, please make sure you subscribe. We'd love to hear your feedback and any questions you might have down in the comments below.